Live.
Hey.
Hey everyone.
Hi everyone.
Welcome to Codecademy Live. My name is Ian. I'm a curriculum developer here at Codecademy.
And I'm Alex DeStassi. I am also a curriculum developer at Codecademy, and we're super excited for today's live stream.
Yeah, this is going to be a great one. We hope you were able to catch us last week as we started going through the visualized data with Python skill path with some of our colleagues. We are going to be spending some time today to continue to go through that path, look at the content together with you, and hopefully answer a lot of your questions.
All right, so I'm going to share my screen.
And hello to everyone saying hi in the chat from all over. We're so glad to have you here.
So just to get started, we're going to navigate to the page that we'll be working with today. So right now I'm on the Codecademy dashboard. And what I'm going to do is I'm going to go over to the catalog that's in the top left-hand corner. And then we're going to choose one of these subjects over here. And for our course, we're going to go into data visualization. And we'll see that the first thing that comes up, and the only thing, is visualize data with Python. So you're just going to want to go that way. We can see we have our path progress. So if you joined us last time, you went through introduction to data visualization. And today we're actually going to move on from that, and we're going to work with some Python syntax. So you guys covered a lot of information. I know you guys went over some graphs and just general information about data visualization. With this one, we're actually going to take a few steps back, and we're going to learn about Python syntax. So we can see we have three options here: the lesson, the quiz, and the project. All you want to do is click into the lesson, learn Python syntax.
Okay. And if you weren't able to join us last week, just to take a moment and pause and just talk a little bit about data visualization before we jump in. Data visualization is this whole really interesting area and field where we think about how can we graphically represent data that is given to us. And it lets us tell a story with that data and present it in a way that might bring out some new insights and some new meaning or understanding. And to get started with that, we got to go back to the beginning, and syntax in a language is a great place to do that. So if you have no background or experience in programming or data visualization, that's no worries at all. You're in the right place to get started with your learning journey right here. If you do have a little bit of background and experience, you might be familiar with some of these concepts, but always good to get a refresher on the foundations of things. And all of these things that we talk about today will be helpful throughout the entire data visualization journey.
Definitely. So again, we're just going to go back to the basics and to the very beginning, and that's with Python. And actually, Python was my first programming language, so I'm always excited to go back through it. So what is Python? It's a programming language. It's a programming language, and a programming language gives us the ability to communicate ideas in a technical setting. So again, it's giving commands. So in one way, we give commands all the time. I say raise my hand, and I can do that, and just series of commands that we give, and we do this through a programming language. So we do this by conveying our commands to the computer by writing them in a text file using a programming language. So if you take a look at the screen in front of us, we see here we have our code editor, and that's where we see a little bit of code right here. And if you look at the top, you can see the name of the file, and it's script.py. The .py extension actually just tells us that this file is filled with Python code. And when we run the program, it just means we're telling the computer to read our file, our .py file, translate it into the set of operations that it understands, and perform those actions. So the first thing we're going to do is we're going to take a look at these instructions. We're going to change Codecademy. So you can see right here on line 1, Codecademy here. And we're going to have it say our name in the script to the right. Okay, so all I'm going to do is I'm going to go into the editor and take back Codecademy, and I'm going to add in my name. And you can see this line under here. It says hello and welcome plus my name. So now what we're going to do, now that we've completely written our file, is we're going to run our code. So you can see at the bottom of the code editor, we have that blue button that says run. Now, when I click it, we see that it processed and our output comes to the right of the screen. So right over here, we have our output terminal, and it says, hello and welcome, Alex. So again, this was our first program. And with that, we'll just move right along into the next exercise. Ironically, the first thing we're going to do is show how to tell our computer to ignore part of a program. And what we're going to do is we're going to create something called a comment. So a comment begins, as we can see over here in the narrative, it begins with a hashtag. And what this does is any text that comes after the hashtag will not be run. So it's just going to be ignored. And there's several uses for comments. And I would say that's the difference between like good code and great code. Great code has comments. So a few things you can do with comments is provide context for why something is written the way it is. So again, when you write code, there's a very good chance that someone else might need to read it one day. By writing comments, you can document what's happening inside of your program. That way it's readable to other people and that they can understand your code. And actually it's useful for yourself too. So a few things you can do with comments. So for example, one thing to note is you may be writing a program and today you understand what it does, but you might not remember what it does in about a week. So it's important to have your comments ready, and that way you know what you've done in the past, and it'll just help you as you go through and continue writing your code. So we went through the first two. You talk about why something is written the way it is, helping other people read the code and understand your own code quickly. And finally, you can ignore a line of code and see how a program will run without it. So if you're going through code and you're like, I'm not sure why this works the way it does, or I think there's a better way to write this, but I don't want to delete any of my other code, you can use a comment. So if you write code inside of a comment, remember that code will be ignored. Okay, so looking at our instructions, 1 second. Great. Documentation is an important step in programming. Write a comment describing the first program you want to write. So all I'm going to do is in my code editor, I'm going to write that hashtag, and that's going to begin our comment. So you can see that any code that I write after it is going to be in that grayed out text. So that'll let you know that you're working with a comment. So let's say the first program I want to write is just says print hello world to the output terminal. Okay, so right there we have our first comment. And if you're ever confused about one of the instructions that you see in a lesson, be sure to check out this hint here. So where it says stuck, get a hint with the yellow background, if you just click that, you'll get a hint to help you along with your code. So you can see, start your comment with the hashtag symbol and write the rest of your comment afterwards.
Now, Alex, let's say I am writing some code and I have a lot of feelings about it because I'm really excited about this piece of code that I'm writing. And I start putting in some comments to explain what I'm doing. And I have like a big paragraph, a chunk of information about my code. Is that something that I'd maybe want to do in this case? Or do you think maybe I should change that filter down a little bit, make it a little more kind of precise to what specifically is going on with the code?
Ooh, that's a good question. I think you definitely want to be as specific as possible when writing out your comment. But what do you think with that? What would you answer for your own question?
Yeah, no, so sometimes I think I will write a lot of information and then I think, okay, what's going to be most clear for either myself when I'm looking at this later on, or for someone else down the line who's taking a look at this code. So I don't want to over inundate them with too much information. So I kind of just will think, okay, what context do they need to understand what is going on here if I'm not by their side to explain it to them. So I don't try and go too overboard, but just keep it informative and to the point.
No, I completely agree. And actually, one of the things I like to do when I write code, I like to use comments just to create a little header for it. So with me, if I'm writing out a program, so let's say I'll start off and I'll just say like the file name. So in this case, we have script.py. Then I'll say who the author is, just in case you need to get in contact with them. So I'll just put my own name. And then usually I'll add a date, and this is the date that I started, but if I edit my code later on in the future, I'll change the date around so that it says maybe last edited or just something along those lines. So today is May 26th, 2020. And then finally, I'll just write out the purpose of the program, and I'll just take this code, this comment right here and put it back. And this just gives an overview of what I want the entire program to do. So it doesn't have to go into too much detail, just a general idea. So if someone looks at your program, they think, okay, this is what the program does. And then as I go through the code, I'll try to write it above the code I write just to give a simple explanation. But just like Ian said, you want to be very concise and specific and try to just get to the point. Great, so I'm going to run this and we can see that this worked because we got that little green mark over there. So now we can continue on with our code.
One actual question that I want to field quickly from the chat that I was seeing both on Facebook, and pointing that out, Alex, is how we can write multi-line comments in Python. And this is a really helpful tool if you don't necessarily want to be using that pound or hashtag symbol on every single line. So I don't know, Alex, if you have experience writing multi-line comments in Python before?
I actually don't think I do. What is the right syntax for that?
Yeah, and this is one of those things that can often change in between language and language. And sometimes when I'm switching, maybe from Python to R or to JavaScript, I'm like, hey, what's the right syntax? So in Python, if you go and put a set of triple quotes right at the beginning, so you do 1, 2, 3 quotes in a row. And then that will kind of begin your multi-line comment. And then if you do another set of them at the bottom, that will end your multi-line comment. So yeah, you can start putting in any text you want in between.
Oh, interesting.
Yeah, so like, let's say maybe you had a function, and that's something that we'll be discussing in a future lesson. But a function is kind of just a piece of code that you've encapsulated with a name so that you can kind of repeat the same code whenever you need it. But if you wanted to explain what maybe that function is doing, you can add a multi-line comment right beforehand that says, hey, I given this information, and then I output this information. And so, yeah, it might be useful to have more than one line there.
Yeah, see, I did not realize that. We're all learning something new.
Yeah, super helpful one there.
And again, you can see when I run this, we don't get an error. So you can see that it's just ignoring all of the text that we're writing, all of our comments. It will not have an effect on the program that you're writing. Okay, no, that was great. Thanks, Ian. Cool, so moving right along, now we'll talk about print and print statements. So basically what we're going to be learning in this particular exercise is how to get our program to communicate. And so this is often basically what we see in our output terminal, that's what our computer program is actually communicating to us. So what we're going to talk about is how we can do that. And in Python, it's because we use something called a print statement, which is used by the syntax print. So the print function is used to tell a computer to say something, to talk. And when we write messages in our print statements, they should be held inside double quotes. So let's take a look at this example right over here. So we have a quote from Mary Shelley's Frankenstein, and all it says is print. We have an open parentheses, Then we have a chunk of text that's held together in double quotes, and then we have a closing parentheses. So that's basically all we need to know about our print statements and what it looks like. So in the above example, we direct our program to print an excerpt from a notable book. The printed words that appear as the result of the print statement are referred to as output. And so the output of that specific program will be that exact text that we saw. There's something at work in my soul which I do not understand. And that's basically it with the print statement. And our first instruction is to print the distinguished greeting, hello world. Often if you're not too familiar with programming, often the first thing you do when you're working with a new programming language is try to just print out hello world. So to write this out, all I'm going to do is first print, and we can see that the text changed as soon as I finished writing print. And that's because print is a keyword. It's known to Python as a keyword that does something. Okay, so we have our print, and then I'm going to open up those parentheses. So we have a pair of parentheses, and now we're going to write something in there. So again, so what I'm going to do is I'm actually going to give ourselves some errors for a bit. So just stay with me. So if I just wrote print hello world, no parentheses, if I run this, we'll get an error. And we'll talk about errors a little bit more in this session. And it says syntax error, missing parentheses in call to print. Did you mean print hello world? So you can see it's telling us that if we want this to work, we need those parentheses. So I'm going to fix that. All right. And then the other thing I'll do, we're going to get one more error, guys, is I'm going to take these quotes out and we're just going to leave hello world here. Oh, so now we have a different syntax error, invalid syntax. And that's just because the software has no idea what this hello world text is. And that's because we need to have it in a string, which we'll learn about. But basically, if we're going to print text, you're going to want to put it in double quotes, and that's important. So now I'm going to run this program again, and we can see that one, we did it right because we got that green check over under the instructions, and two, we see hello world in our output.
Now, Alex, let's say I've been coding elsewhere on my own before in Python. I've seen it out in the world, and I was able to go ahead and make a print statement without those parentheses. What might be going on in that case?
Thank you for bringing that up. So that's actually one of the big differences between Python 2 and Python 3. And basically, when we say Python 2 and Python 3, those are just the versions of Python. So I noticed that when I first started programming, I didn't need those parentheses. I could just write print hello world without the parentheses, just the quotes, and we were good to go. After the release of Python 3, that changed and you started to have to include those parentheses as part of the syntax.
Awesome. Thanks.
Right,
Alex.
does that sum it up, Ian?
Yeah, that basically sums it up. We have a new syntax in Python 3 that just uses those parentheses.
It was super frustrating after that initial change.
Definitely, change is always hard, right? Changing from one version of a language to another, or switching languages. But it's always also fun to overcome those obstacles, figure out what's going on, and learn something along the way.
Yeah, and to me now, now that I've used this syntax for so long, it would be weird for me not to include it. All right.
Just like when the apps on your phone gets updated to a new interface, you know, that first day you're like, oh wow, this is weird, and then 2 days later, you forget about the old interface.
Exactly, you just got to go with the change.
I just want to jump to the chat really quick. I want to say thanks to Adam for pointing out that actually when we are doing those multi-line comments, or what we were calling multi-line comments in Python, those are actually doc strings, which are a little bit different, but they essentially enable us to create something like a multi-line comment in Python. And so thanks for calling that out, Adam.
Thanks, Adam.
I know we also have some people in the chat who are saying, I'm really interested in data visualization. Are we going to get there? And this is just like we were mentioning, the first step in the series where we're going to be building up to creating visualizations. And we're starting out here with syntax, which is really a core foundation of programming. And this is going to be really helpful for us when we move down the line in order for us to create those visualizations that I know you're really excited about, and I am too. So yeah, we'll get there in time.
Yes, definitely. And it'll be great when we get there. And just like Anne was saying, this is just building the foundation so we can get to data visualization and everything will be understandable, we hope. Okay, so moving right along, strings. So you may have heard me call something, the text that we were working with before, a string in the last exercise. And so computer programmers refer to blocks of text as strings. In our last exercise, we created the string hello world, and a string is either surrounded by double quotes or single quotes. It doesn't matter which ones we use as long as we are consistent. Let me just refresh this. There we go. Okay. And we'll also talk about this a little bit more, but strings are also considered a data type, and you'll know what that means in a bit. This is just a hint. So what we're going to do is we're going to print our name using the print command. Okay, so just like before, we're going to get out that keyword print, type that into our script.py, open up those parentheses, and then I'm just going to write in my name. And right now I'm using double quotes. So here we go. I'm going to run this, and we can see that this was correct and we did it correctly. Okay, so if your print statement uses double quotes, change them to single quotes or vice versa. Okay, so let's change this. So one, we're gonna get an error. I'm doing this on purpose. What if I just leave it? What if we say forget consistency and run our code? Well, we'll get an error. So that's why you need to stay consistent. If you change it up, you will just get an error. So we'll fix this just by making sure we have a consistent single quotes on both sides of our text. And when I run this, we can see that it works now, and Alex prints out to the output terminal. And then one thing just to know, if you're going through this and you're like, there's no way I will remember all of this information you're throwing at me, don't worry about it. It takes a while for it to really get ingrained in your head. But one great way to keep reviewing this material is taking a look at our cheat sheets. So you can see right under the instructions where it says concept review. If you want to quickly review some of the concepts you've been learning, take a look at this material's cheat sheet. So we can see this is all about Python syntax. And it just goes over all the different things we'll go over through this lesson. It's just a quick way for a quick review. And it's a really helpful resource. So again, if after this course you're like, wow, I don't want to forget all this stuff that I learned, this cheat sheet might be perfect for you.
Cheat sheets are really, really great. One of the things I love about the Codecademy platform. Some people print them out, some people leave them up in another tab, lots of cool things you can do with them, but always a great resource to have.
Mm-hmm. Okay, so we'll just keep moving right along. Variables. Ooh, okay, this is a fun one. Programming languages offer a method of storing data for reuse. So if there's a piece of data that we want to reuse in our program, whether it's a greeting or a date or a user ID or just a very important number that we're going to be revisiting again and again throughout our program, we can use a variable. And when we have a variable, we're basically able to name a piece of data that we can store and call whenever we want in our program. So they're super useful and a very important part of programming. So if we want to do this, we can create a variable which can store a value. And in Python, we assign variables by using that equal sign or the assignment operator. So you can see right over here, we have an example and it just says message string equals hello there. So the name of our variable in this example is message underscore string. And then the value that this variable is holding is the text hello there. And now we can see right over here, we can print out our variable And when we print out the variable, the output will be the value that the variable holds. Okay, so in that above example, we stored the message hello there in a variable called message string. Variables can't have spaces or symbols in their name other than an underscore. So that's important to know. We can't have a variable called 789 message. That won't work. But we can have one called message 789. So just make sure we understand that difference. Let's see. So, other things with variables is when you name a variable, try to have it be related to the data that it's holding. Having a variable called random and it stores your birthday, probably not the best name for it. But if you want to store your birthday, maybe name the variable birthday. So always try to keep that in mind, because something important with coding is the readability of your program. Before, we discussed how comments are important and how they can help us document our code so that it's more readable. But proper variable namings, that's another top one.
One of the least fun things that sometimes happens in programming is I maybe worked on a file and maybe a few weeks later I come back and I see these variable names and there's something like num1, num2, val1, val2. And I'm like, wait, what were these values representing? What were the numbers? So those descriptive names can be helpful for yourself down the line for sure.
Absolutely, because again, you might write a program and the day you wrote it, you're like, yes, all of this makes sense. And then you revisit it like the next day or like a week or two later, and you're like, oh my goodness, what on earth is this? So readability, it's good for others and it's good for you. Great. So it's no coincidence that we call these creatures variables. If the context of a program changes, we can update a variable, but perform the same logical process on it. So let's take a look at this code example we have over here. So first, we have a greeting, and we know that it's a greeting because there's a comment telling us that. And we have a variable message string that has the value of hello there. And we print it, and it prints hello there to the output terminal. Underneath, we have a comment that says farewell. So what we have is the same exact variable, message string, but we changed the value. So once this goes through, the value of message string is no longer hello there. It's been updated to hasta la vista. And when we print it, hasta la vista will be the text that is outputted. So that's just something you want to know. We can change the value of our variables. Okay, so let's take a look at our instructions. Update the variable meal to reflect each meal of the day before we print it. So if we look at script.py, we have this little program, and what you notice is meal comes out several times. So first we have our breakfast, which is an English muffin. And when we print it, it'll say breakfast English muffin. But now let's update our meal to be lunch. So I had a peanut butter jelly sandwich for lunch. Oop, that's not how you spell it. Cool.
Always love a good PB&J sandwich.
Thank you, it was great. And now dinner. So let's see. So it does say that we're gonna have to update the meal to be dinner. So all I'm gonna do is I'm going to write meal. I'm going to use that equal sign, that assignment operator, and we're gonna change the value of meal. And for dinner, I'm going to have pizza today. Okay, so this is our program, and now I'm gonna run it, and let's see what comes out in that output terminal. So you can see right over here, breakfast, an English muffin, lunch, peanut butter jelly sandwich, and dinner, pizza. So we were able to output all these different values. However, it was the same variable that we used. We just changed the value associated to the variable. Great. Okay, so we'll move right along with this. Errors.
And before we jump into the errors exercise, which I think is actually one of my favorite exercises in this lesson. In the comments, I see Adam saying that he thinks it's good to think about concepts instead of maybe syntax, or there's more importance to concepts than to syntax. And maybe why are we thinking about syntax here? And I would say I agree with you that concepts are the most important thing in programming. They kind of go through everything that you are learning, and if you understand the concepts, it can often make the syntax easier sometimes. But I also think it is key to have a good foundation in the syntax of a language, and that also ends up helping you when it comes to understanding concepts of maybe more difficult things or different aspects of the language. And you are also able to get a better feel for concepts when that base syntax is kind of in your tool belt, and you're not spending all your time thinking about, oh, okay, is this the right way for me to do something? Of course, you can always also go and look up syntax online. And the cheat sheet, for example, is a really great place to go and check the Python syntax if you want to go look at it. But I do agree with you that concepts are just as important, if not more, but it's always good to get that foundation in syntax.
Great points. Thanks.
Of course.
Okay, so moving on to errors. So humans are prone to making mistakes, and we're also typically in charge of creating computer programs. To compensate, programming language attempt to understand and explain the errors made in their programs. So Python refers to these mistakes as errors, and they'll point to the location where the error occurred with that little uptick character. When programs throw errors that we didn't expect to encounter, we call those bugs. Programmers call the process of updating the program so that it no longer produces unexpected errors as debugging. So there are two common errors that we can encounter while writing code in Python, and that's a syntax error and a name error. So a syntax error means there's something wrong with the way your programming is written. Maybe the punctuation there doesn't belong there. Maybe the command's not where it's expected to be, or even a missing parentheses can all trigger something of a syntax error. Now, a name error occurs when the Python interpreter sees a word that it doesn't recognize. So this could be code that contains something that looks like a variable but was never defined. That would throw a name error. So let's see our instructions. So first off, the code that we see in script.py, they're gonna throw us some errors. So you might encounter a syntax error if you open a string with double quotes and end it with a single quote, which we saw earlier on in this exercise, in this live stream. So we're gonna update the string so that it starts and ends with the same punctuation. So we can see on line 1, this string has mismatched quotation marks. So instead of the single quotes, let's have them both be double quotes. So we're going to change this. Okay, so this will fix the error in our first line. And then in the next one, this is a name error if we try to print a single word string but fail to put any quotes around it. So Python expects the word of your string to be defined elsewhere, but can't find where it's defined. So we can add quotes to either side of the string to squash this bug. And so I'm just going to run this as is, and we're going to take a look at that error really quick. So once again, we can see the first one prints out. This message has mismatched quote marks. But then that second line, that print abracadabra, that's going to throw us an error. So you can see file script.py line 2, and that's where it is, script.py in line 2. We can see even the very line of code that it's having an issue with. We have a name error, and the name abracadabra is not defined. So to fix this, we're just going to add some quotes. So I'll do single quotes for this one. Okay, so if I run this, there we go. So now we have no more errors, and we can continue on with our program. I also often find that when you get an error, it's very frustrating, and you may feel like you have to give up, or perhaps coding isn't for you. Errors are such a common part of programming. So it's just about being able to read them and getting through them and problem solving. So if you feel frustrated, that's valid, but definitely don't give up and keep trying to fix your code. Okay.
I also like to think of errors as a sign that I am exploring something new with my code that I haven't tried before. Just because if you're writing code and you aren't seeing errors coming up, maybe you're writing code that's very similar to what you did before or on the same topic, which is also great. But when I'm looking for that challenge or to try something new, errors will surely be coming my way too. I always try and think of them as like a good sign.
I often learn the most when I'm debugging my code. That's when I figure out what it does. Like, that's when I have the best idea of what my program is doing.
Totally.
Okay, so now we're going to talk a little bit about numbers. So computers can understand much more than just strings of text. So Python has a few numeric data types, and it has multiple ways of storing numbers. Which one you use depends on your intended purpose for the number you are saving. So the first one we'll talk about are integers. In Python, they are sometimes known as ints, and that's when you're using whole numbers. So no decimal points, and it contains all counting numbers and as well as their negative counterparts. So we can see with some of these examples, 1, 2, 3 integers, -1, -2, -3, also integers. So some examples of when you would use an integer is if you were counting the number of people in the room, number of jelly beans in a jar, the number of keys on a keyboard. Again, those are the examples of when you would want to use an integer. Now, the other data type that we could use is something called a floating point number or float. And the values held by these data types are ones with decimal points. So this is good for if you're trying to save a data point that has fractions in it. So for example, if you were measuring the length of your bedroom wall, calculating the average test score of a 7th grade class, or storing a baseball player's batting average for the 1998 season. That was a very specific example. But those are good times of when you would use a float. So numbers can be assigned to variables just like we could with strings. And we can use them literally in a program. So let's take a look at these two examples here. We have our variable called an int, and it holds the value 2. And you can see that it's a whole number, no decimal points, so it's an integer. And then we have the second one that's called a float, and that has the value of 2.1. And because it has a decimal, we know it's a floating point number. And right over here, we can see that we can just we can use these values in our program. So right over here, we have print an int plus 3. So it takes that value over here, 2 plus 3, and then it prints out that final value of 5. Okay, so one thing to know is floating point numbers can behave in some unexpected ways due to how computers store them. And that if you want more information about this, definitely review Python's documentation on floating point limitations. So that link is there for you if you're already in this exercise, and we recommend that you check it out. Okay, so let's take a look at these instructions. A recent movie-going experience has you excited to publish a review. You rush out of the cinema and hastily begin programming to create your movie review website. The big screens, greatest scenes decided by a machine. I love that. Create the following variables and assign integer numbers to them. So release year and runtime. So we're going to do that. So release year, and we'll have that be 2020. And you can see no decimal, so it's an integer. All right, and the other one is runtime. And that's going to be, I'm going to say it's 120 minutes. So I'll leave that value at 120. So let's run this code. And you can see that all is good, so we can continue on. Now create the variable rating out of 10 and assign it a float number between 1 and 10. Okay, so let's do that.
Was it a good movie or was it an okay movie?
Ooh, I'm gonna say it was a not great movie.
Not great.
It's a not great movie. It got a 3.7.
Ooh.
It's not great. The critics have decided. So I run this, and so let's see. It gave us an error, so let's see what the problem of that is. Oh, so my issue was I named my variable wrong. Instead of writing out 10, I actually wrote out 10, T-E-N. Okay, that's on me. So we just fixed this little error. We run this, and now we are good to go. Okay, so I'm actually going to stop sharing for a moment, and I'm going to let Ian take over for the next section.
Awesome, thanks so much, Alex. And so I just want to quickly jump to the chat. I see someone asking about why are we talking about maybe Python 3, if there's Python 3.8 out, and kind of just questions about different types of versions of Python. And so when typically people say Python 2 or Python 3, there's a bunch of different versions of those two releases. But people won't necessarily say like Python 3.8 or 3.7 or 3.6. They'll just say, oh yeah, we're working in Python 3. There are minimal differences, or there are differences between those different releases, but generally they're similar enough that you can just refer to them as Python 3. Or if you're working in the older version of Python, you would say Python 2. So we are working here today in Python 3. Great question. All right, I am going to go ahead and share my screen, and we will keep running through the lesson. Awesome. And so we were now moving over to exercise 8, where we are talking about calculations. And so now that we've discussed variables and different types of numbers, ints and floats, we can do different things with variables that are storing those integers and floats to do the same kinds of calculations that we would maybe do on our calculator if we were in math class, or on a sheet of paper. If we're just trying to maybe do the tip at a restaurant, or in other places in life. And we are able to use in Python the same kind of operations that you would do anywhere else. So the ones that we'll talk about here are addition, subtraction, multiplication, and division. So we can see here in the code block that we can just go ahead and take integers or floats and directly use these different operation symbols to make certain calculations. So if we wanted to do 573 minus 74 plus 1, we can just go ahead, use the minus symbol and the plus symbol in order to subtract 573 and 74, and then add 1. And if we put that inside of a print statement, we will get 500 out. Similarly, if we go ahead and, sorry, just refreshing my page there. If we wanted to do multiplication, we'll use the star symbol to represent that. And if we print 25 times 2, it's going to give us the multiplication of those two numbers, which is 50. Similarly, we can do division. And we see here that when we are doing this division, we are getting an answer of 2. And you'll see also specifically that we're getting an answer not just of 2, which would maybe be an integer, but we're getting 2.0, which represents a float. And so when we are doing division in Python, we will automatically convert that answer to a float. So if we put in 2 integers as inputs to our division, so we do 10 divided by 5, it's going to spit out the float version of 2, which is 2.0, instead of just the integer version, which is 2. This differed from previous versions of Python. So if you were working in Python 2, you would see a different answer there. Division can have its own error, which if you are a math person, you might have encountered before, which is division by 0. So that is something that we do not want to do and will cause an error. So I'm just going to restore my workspace here, and we'll go and do this checkpoint. So here it says, let's print out the result of the equation, 25 times 68 plus 13 divided by 28. So I'm going to go and create my print statement. And inside of here, I will just do 25, use the star symbol for multiplication, do times 68. I will then add 13 with the plus symbol, and then I will use the / to do division and divide by 28. And when I run this code, we get out, let me do this just to make sure that we're working. And there we get a check. Great. We get 1,700.46428, so we're getting out this float here. So we're getting all of those decimal places. So very similar to how you would work on a calculator. Now, we also are able to take advantage of variables, which we talked about earlier, in order to do calculations. And so we don't necessarily need to just use the actual integers and floats to do calculations. We can assign those values to variables and then use those more meaningful variables that we were talking about giving good names to do calculations that might make more sense in a certain context. So we can see here that we're creating a variable coffee price, and we're setting it equal to 1.50. So we're saying here, if we went to the store, maybe the price of a coffee is $1.50 if we're in the US, or 1.5 euros, or 1.5 pesos, whatever your denomination is. And then let's say we wanted to get 4 coffees at the cafe. So we're picking up some coffee for our friends. So we can all do some work. We're going to create a variable number of coffees and set it equal to 4. And we're using this equals sign or the assignment operator to assign a value of 4 to that variable number of coffees. We are able to do some calculations now on those variables using those operators that we were talking about in the previous exercise. So if we wanted to see what was the total cost of making this purchase, we would do the coffee price times the number of coffees, and we could put that inside a print statement, and we would get 6. So it's 1.5 times 4. 1.5 being the coffee price and 4 being the number of coffees to get 6. We are also able to go ahead and update the price or update the value of one of our variables. So let's say the coffee shop decides to raise the price of a coffee to $2, €2, whatever denomination we're working in. They're trying to copy that Starbucks, raising the price strategy. And we can now go ahead and make the same calculation as before, do coffee price times number of coffees, and we will now get 8, since our coffee price is now 2, but the number of coffees is still 4, and 2 times 4 is equal to 8. So let's jump over to the checkpoint, and we see here we decided to get into quilting. Trying to get a little creative. Maybe we're in quarantine and this is a new skill that we've picked up. To calculate the number of squares you'll need for your first quilt, let's create 2 variables, quilt width and quilt length. Let's make this first quilt 8 squares wide and 12 squares wide. So I will do quilt width is equal to 8 using that assignment operator. And then I will do quilt length is equal to 12. Can run my code here. And now we are asked to print out the number of squares you'll need to create the quilt. So since the width is 8 and the length is 12, I'm going to go ahead and multiply those 2 numbers together to get the total number of squares. So I will do print statement because we want to put that inside that print. And then I will do quilt width times quilt length. And now what I could have done inside this print statement is just wrote print 8 times 12. But let's say it's a few weeks from now, or I pass this file over to someone else that I'm working with on this quilt business, and they're looking at this code. And while I know that 8 and 12 represent the quilt width and the quilt length, they might not know that. They might not have that context. So by creating these variables with descriptive names and then using those in the calculations, it makes sense to other people besides myself what is going on here in the code. Now we see, it turns out that the quilt required a little more material than we have on hand. Let's only make the quilt 8 squares long. How many squares will you need for this quilt instead? So it seems like we're changing that length from 12 to 8. So I can just go ahead and update the value of my quote length variable. And now if I rerun my code, we just redid that calculation now with our new quote length value. And now we can see that it's 64 squares. So we did a reduction from when the quote length was 12.
And then actually we do have a question. So Chancellor was asking if we'll be covering for loops and while loops today. And actually the answer to that is no, because we only have about 9 minutes left of today's stream. However, the content is out there, and we'll possibly get that in the next one of the next few live streams, or if you want to on your own, just go through the course, our Learn Python course. This could be super helpful.
Yeah, that's a great question. So we'll today cover one more exercise right here, and then we'll part for today, just so that we aren't going over time. But continuing on from here, we will be having other sessions that will pick up on this content and help you get further through the visualize data with Python skill path. So we'll talk about that in just a second. But great question. Awesome. So for maybe the last thing that we'll cover today are exponents. And so if you've done math class outside of programming, you might have run into exponents beforehand, but they are a really useful tool in math that allows us to multiply numbers together repeatedly really easily. And so in Python, the way that we can do exponents is by using the asterisk or the star symbol, but writing it twice. So we'll use the asterisk once for multiplication and then twice for exponents. So for example, if we wanted to raise 2 to the 10th power, and so just to go over that really quickly, what 2 to the 10th power is saying is let's multiply 2 by itself 10 times. So that'd be 2 times 2 times 2 times 2, 10 times. So to do that, we would do 2 and then 2 asterisks and then 10. And if we wanted to do, let's say 8 squared, which is, and for any squared value, it's multiplying that one number by itself. We would do 8 double asterisk and then 2. And then if we wanted to do 9 cubed, which is the same thing as saying 9 to the 3rd power, we would do 9 double asterisk and then 3. We're also able to do fractional exponents, which some of you might know or think of square roots or different roots. So for example, the square root is the same as an exponent that is 0.5. And we could do 4 double asterisk, then 0.5. And we'll quickly do a checkpoint, and then we'll wrap up for today. So we really like how the square quotes from the last exercise came out and decided that all quotes we make from now on will be square. Use the exponent operator, print out how many squares you'll need for a 6 by 6, 7 by 7, and 8 by 8 quote. So what we would do here is for squares, we will take the length of one side. So let's say in this case it's 6. We will use our double asterisk. And then since we want to square it, we are going to use the 2nd power. And I could do the same here for 7. I'll do 7 double asterisk 2 for 7 squared. And I will do 8 double asterisk squared. And if we print that, we will see we get 36, 49, and 64. We would love to continue more for today, diving into Python syntax, but we are running short on time. So there are some things that we want to leave you with before we go. So first, just want to say thank you so much for joining us here today to chat about Python syntax. I know a lot of you are really excited about data visualization, and this is a foundation in order for us to get to creating our own visualizations. So we will be getting there in time. We really recommend that you continue to go through the Python syntax course. There's a few more exercises here that are really great for setting that foundation. A few other things that we would like to mention. There will be another stream on Thursday featuring both myself and Alex for our Codecademy Pro subscribers, where we will get some time to talk in a more one-on-one way. We can go through some content related to Python syntax and data visualization, but we're also open to chatting with all of you about different questions that you have, maybe related to Python syntax or data viz, or just having some time to chat in a smaller environment. So we really hope that you'll join us for that. And we just want to quickly show you how you can go ahead and find that stream for Thursday. So if you go to codecademy.com, and we'll let it load. And if we scroll down from the homepage of Codecademy, we can see, if we scroll down towards the bottom, we have our community at Codecademy section, which is great for, in general, finding out information about events that are happening, places that you can communicate with other Codecademy learners, and really find an online community to help you in your journey of learning to code. And so if you go to this event section right here, you can click this register button, and that will bring you to a page with all of our events. So you can see that we have an event on Thursday, May 28th, for our pro members to come join a Q&A on Visualize Data with Python with both myself and Alex. If you aren't a pro member, there are other events that will be continuing to happen for you as well. Next week, we will have the famous Kenny and the famous Alex. Different
Not
Alex.
me. Other Alex.
All the Alexes at Codecademy are actually really amazing and great, and a pleasure to work with. But you will be getting a different Alex, Alex Kuntz and Kenny, who will be joining everyone for the next phase in going through content of Visualize Data with Python skill path. And so they will be working on the functions module and kind of picking up where we left off. So we really recommend tuning in for that. And they will also have another Q&A session there for them as well next week. So go to this page, register for these events. We are looking forward to seeing you there and to continuing to interact with you all while maybe you're at home, and just trying to help everyone out with learning more about data viz. I love data viz, so it's exciting for me to be here with you all.
Also, if you're interested in learning more about our live streams and being notified, be sure to subscribe to our YouTube page or follow us on Twitch. And that way you can get notifications about more upcoming live streams.
Definitely, yeah. Hit the like and subscribe button, hit the follow. We're excited to interact with you. And so we hope to see you in those future sessions. Thank you all so much for joining us today. Again, my name is Ian.
And I'm Alex. Thank you so much.
Yeah, pleasure to spend the day with you. Hope you all learned something, and we hope to see you soon.